Hello, welcome to this video on triangle rules. Now, sine and cosine rule are possibly topics that you've encountered at GCSE if you studied it at higher tier. If that's the case, feel free to blast through the chapter, this is chapter 7, and go through the questions at your own pace and just use this video to double check things. If this is new to you, feel free to use this as a bit more of a walkthrough. Let's jump in. Hello. So here's the sine rule. We're going to use it to find missing sides or missing angles in non-right angle triangles. And there's two rearrangements of it, I guess. I've got a rearrangement on this left side here, which have got the sides on the top, little a and little b. And I've got a second version of it over here, which has got sine a and sine b, the capital letters, the angles on the top. And essentially, if you're trying to find a side, you're probably going to want to use the version with sides on the top of the fractions. It just means that there's less rearrangement to do overall. And similarly, of course, with the angles, if you want to find an angle. So let's have a look at an example here. We are going to try and find an angle in this triangle. We know two sides, 4 centimeter and a 9 centimeter side. We also know an angle here is 75 degrees, and we're going to try and calculate this missing angle down here. If you want to work ahead and have a go, feel free to work a little bit ahead. The answers for all of these are in your booklets. And whenever you're ready, just speed through the video and I'll run through the answer. So because I'm trying to find an angle, I'm going to write down the version of the sine rule where the angle expressions are on top. And I'm going to replace everything that I can. So I know that side A is 4. That's going to go here. I know the side B is 9. I'll replace that there. And I also know that angle, capital B, is 75 degrees. So I'm going to replace that within the sine function over here. Amazing. And now there's only one thing in this formula that I don't have, which is the capital A. I'm going to rearrange this expression, move the 4 and multiply. I'm going to write this on the next line. It's going to look like this. Amazing. I think I can go ahead and type this quantity in on my calculator. Let's do that. It's going to be 4 sine 75 divided by 9. And that gives me an expression. Which doesn't really seem like a reasonable answer for my angle. But what we're going to need to do to get that final angle, similar to what you might have done in trig before, is use the inverse sine function, or shift sine, on your calculator, as you might have called it then. Press shift sine, and I'm just going to press answer of pure laziness. Awesome, and then that gives me my angle. Very good. I can also use the sine rule in situations where I know two angles and I'm trying to find a missing side. So once again, feel free to try this out ahead of me and see how it goes yourself. I'm once again going to write down the sine rule, but because there's a missing side missing, doesn't matter. I'm going to write the formula with the sides on the top of the fraction. And then once again, I'm going to replace everything that I know. Got rid of the one thing that I didn't know. Let's keep that there. That was a 10. My little side A, that is 80 degrees. and this is 45. Lovely. I'm going to move this up the left side, multiply by it. And if I type this quantity in on the calculator, I'm hoping that it's just going to give me my answer straight away. Let's see how it goes. Fantastic. It has indeed given me my value for my side. So a little bit less work to do for the versions where there's a missing side. Hello, welcome back to this little series of triangle videos. And in this one, we're talking about the cosine rule, which is another rule that you can use to find missing sides or missing angles. The thing that makes it different to the sine rule is we might know different combinations of things. So we can use the cosine rule if we know 3 sides and we're trying to find a missing angle, or 2 sides but with the angle between them. And we're going to use that information to find a last missing side. So we're going to run through both of these examples. As usual, please feel free to pause this and try them out yourself. And I will just run this through in my own time. You can like skip ahead or play me on like 1.5 speed or something if I'm going too slow. So in this example here, we've got 3 sides and we're going to try and find an angle. So it makes sense to use the version of the formula that has been rearranged to have the angle on its own, because I'll be able to substitute in everything on the right hand side and there'll be a little bit less work to do overall. If you haven't seen this version of the formula, feel free to try and rearrange this expression on the left and make cos A the subject, and you'll see how all the parts move together and they do end up being equivalent expressions. Let's write down this rule then. So I'm going to start by replacing all the sides. Oops, jumped. Replacing all the sides I know. So I'm told that A, the side A, is 11 centimeters. So let's replace the A with an 11. And replace B also with 11. There's a B here and there's a B down there. C back in just for a second, and I can also replace C of course as well, so let's do that. That's going to be a 15. Wonderful. So right hand side is looking very numerical right now, so we are going to type all this in on the calculator and see how it turns out. Those observant amongst you might realize that we've got 11 squared, take away 11 squared on the top, which that's just going to cancel, right? You're just going to get 15 squared on the top, which I think is 225. And that is our simplified fraction, that cancelled down version. Like in the sine rule problem, this doesn't give you the value of the angle straight away. We're going to need to use the inverse cosine function. Find this. Shift cosine. And I'm going to press answer on the calculator because it's got that 15/22 saved. And that indeed gives me the angle, 47.01 degrees, which will round to 3 significant figures there. Neat. Let's also use the cosine rule in this type of situation where We know two sides, and we also know the angle between them. And we're going to try and use this information to find the last side of the triangle. So this time I'm going to write down the version of the cosine rule where a is the subject of the formula. So it's a squared, and I use the less chunky pen, equals b squared plus c squared, Pythag, take away 2bc times cos of a. And a squared is a is the quantity I do not know. I'm going to replace b. And I'm also going to replace c. I'll tell you what, I'm going to write it all in one line here. Let's replace capital A while we're at it. Let's just do it all in one go. So it's going to look like this. B squared, it's 10 squared. C squared, that's 9 squared. 2 times B times C is going to be 2 times 10 times 9. And cos of A is going to be cos of 50. Right, lots of numbers going on the right hand side, so let's tidy all this up, see what we get. 10 squared plus 9 squared, take away 2 times 10 times 9 times cos of 50. Get a reasonably big answer, 65.29. Doesn't sound plausible for a triangle side, because that's a squared. Get the value of a, I'm going to need to square root it. On the calculator, I'll just type in square root of the answer. And that is going to give me a value of 8.08, sorry. Wonderful. A useful tip that you can keep in mind with either sine rule or cosine rule is that we don't have to have it written with a and b. So you might have some triangles with totally different sets of labels, x, y, z, for example. So the sine rule just applies in these general circumstances. You could absolutely call this x over sine x equals y over sine y. That's absolutely fine. Similarly, you could have a different letter again. So if the information that you knew was x and z, then absolutely we could work with this. What this means often is the sine rule might be sort of re-expressed in terms of sides that we do know. So if there's a missing angle at A, we can just rely on the angle at C instead. Cosine rule, we can do the same thing. So even though the cosine rule normally looks like this, equivalently, we could swap some of these terms around. So we could switch the labels for A and B, and the formula would look something like this instead. And that is still the cosine rule. So a bit of an overview of these two rules and deciding when to use them. I just very quickly write down the formula for the sine rule. We use the sine rule when we know 3 out of these 4 things, and we're going to try and find that 4th thing. So if I highlight 3 of these things, by necessity, I'm going to have to highlight everything on one side of the formula, which means that I need to know a side and its opposite angle in order to use the sine rule. And the thing I'm trying to find is either a missing side or a missing angle. So if your triangle isn't labeled whatsoever, you can just try and look for a matching side, the matching angle, and then another combination of side and angle that you're trying to find out about. The cosine rule, you have a different combination of information. You might have 3 sides with no angles, or you might have 2 sides but without a matching angle, without an opposite angle. You have the angle in between them instead. This is also the version of the rubbish. This is also the set of information that you'll use if you're trying to find the area of a triangle, which we're going to talk about next. Hello, this is part 3, and this is the last formula that you're really going to need to worry about, area of triangle. And you might have seen this before. This is the area of a non-right angled triangle, although equivalently it is equal to these things as well. And notice that all that's happened here is we've relabeled the angles and sides have sort of cycled through. So you've just got 2 sides and then the other angle in all of these instances. Let's have a quick look at this example here. The angles have been labeled, but the sides haven't. So what I'm thinking to do is to very quickly label the sides. So they're always opposite. So this side will be little a, this side will be little c, and the side that I do not know about in this instance is little b. Now the area formula has a few relabelings up here. So I need to use the version that has little a, little c, and the angle at b. And I think I can see that it's this one here. So I'm going to write that formula down and replace everything that I know. So the side is 5, the other side is 5, and the angle is 74 degrees. So let's replace everything in my calculator. Half times 5 times 5 times sine of 74. And that is equal to 12.01. I'm going to call it 12.02 actually if I round to 2 decimal places. And since it's an area, I'm going to go centimeters squared as well. Oh, hopefully that one seems all right. Hi folks. I'm a bit gutted. I've already recorded this once and it was on mute the whole time. I was devastated. But never mind, we're back at it. We're looking at this algebraic example. Now, this is the sort of thing that will be different compared to what you've seen at GCSE. We're still going to be using sine and cosine rule. This time there's going to be some algebra within the lengths. So we got to think about ways to deal with that. Feel free to read it through and try as much of it as you can yourself. I'm just going to work through it here, so feel free to pause me and whenever you're ready, hit play and I'll work through it. We've got this triangle. I'm going to start by labeling the sides with little a's, little b's, and little c's. And I'm going to try and work out what's going on. So I know an angle at B. And because I've got expressions, even though I don't know them exactly, I've got 3 lengths that I know something about, and I know an angle. So I'm thinking between the sine and the cosine rules, if I write down them both, So between these rules, the cosine rule is one that uses 3 lengths and 1 angle, which is the set of information I have, whereas the sine rule uses 2 angles and 2 sides, and I only have information about 1 angle. It doesn't seem to mention any other angles here. So I think my starting point is to write this all down in terms of the cosine rule. Because the angle that I know is at B, I think I'm going to use the version of the formula that swaps A and B around going to look something like this. B squared equals A squared plus C squared minus 2AC plus B. This is going to be my starting point for this question. I'm going to write it down one more time to reinforce that idea. And I'm going to replace everything that I can. So B is x squared, C is equal to 8, and A is equal to x plus 2. So that is writing down an equation satisfied by x. It's got an x in it, right? So that's my equation sorted. I now need to work out what x is. And it looks like this is a quadratic equation or something like that. I don't really like the look of this at the moment. However, those of you that have covered this in additional maths possibly at school, you may know that cos 60 has a nice value. It's actually equal to a half. So what I'm going to do is I'm just going to write this statement down again, replacing the entirety of cos 60 with 1/2. Also going to work out 8 squared, and I'm going to write this as a double bracket along the way. Cool. Let's expand the double bracket. We get x squared, 2x plus another 2x plus 4. And as for the next bit, what I'm thinking, I've got a bunch of things times together here. 4 different expressions times together. When you're multiplying all these things, it doesn't matter which way you multiply them, right? So if you did 3 times 4 or 4 times 3, it would be the same. So what I'm thinking is, if I did 2 times 8 times a half, I did all the number bits first, and then I multiplied it by x plus 2. I would at least be able to work out what this works out as. 2 times 8 times a half, 2 times a half is 1, and then 1 times 8 is 8. So this is going to be working out as 8 lots of x plus 2, which I'll go ahead and expand on the next step. That is the result of my previous bracket, and then if I expand this out, it's going to be minus 8x minus 16. Now this is very much looking like a quadratic equation, so I'm going to write it with x squared as the leading term. I have also got a 4x and a minus 8x, leaving me with a minus 4x. And the numerical bit, 64 plus 4 is 68. Take away 16 is 52. So that's the whole thing simplified. It's not quite a quadratic yet because I haven't got a 0 on one side. However, the existence of an x squared on both sides just means that when I do take this over, x squared minus x squared, it's just going to cancel. So I can just get rid of both of these terms and have a 0 right there. Amazing. And solving this, I'll take the 4x, or the minus 4x term, over to the left. It's going to work out really nice. Those of you with a brain for mental maths know that this will work out exactly as 13 centimeters. Amazing. So I have indeed solved for x. I've worked out that it was 13 centimeters. And this helps me unlock a little bit of information actually. I know that this side B, is actually just 13 centimeters now. And this side, A, I know that x is 13, so it's 13 plus 2, which is a 15 centimeter side. That's made the problem a little bit easier going forward. The second part of the problem, which isn't algebra centric, is just to find a missing angle. We're finding the angle at C. I'm going to put this on my diagram, which is this angle here. Color it in just for fun. How am I going to do this? We could use cosine rule again. I think we've got enough information to use sine rule as well. So we know this side, and we want to try and find this angle. We also know a side and its corresponding angle as well. So yeah, it's enough information to use the sine rule with B and C. So it was an angle that I was trying to find. So I'm going to write it with the angle on the top and the side on the bottom. And I'm going to replace everything that I can. The side I think was 8. And for B it was sine of 60. And the length opposite B was 13. I'll multiply the 8 up. And I will get sine of C is 8 lots of sine 60 over 13. And I'll type that in on the calculator, 8 sine 60 over 13. And I get like a decimal, I guess. And then if I inverse sine that, I'll get my angle. To shift sine of the answer, 32.2 degrees. And it's my face. Cool, nice. Okay, the second and the last of algebraic examples and the last thing of the chapter as well. So well done for making it this far, if indeed you have. Let's have a bit of a walkthrough of this one. In some ways, this one's easier. It's certainly shorter. We've got 3 sides again. This time, 2 of them we have numerical values for, and 1 of them we have an x for. We're also told that cos of BAC, so that is the angle at A, is equal to 2/5. Cos of A. The question says, write down a quadratic equation with x in it and use it to work x out. Apparently x is 12. So since we were given the value of cos A, I think it makes sense to use the cosine rule again. So I'm going to start by writing down the cosine rule. And the thing that's strange about this question, but actually makes it quite a lot easier, is this cos A term we know is equal to 2/5, so we can replace that entire thing with a 2/5. So on this next line, I'm also going to replace everything else I know. And let's label it. So little a is going to be this side opposite A. Little b is the side that I do not know. And C is the 5 centimeter side. All right, let's do that. Let's change everything we can. 11 squared, x squared, and 5 squared. 2x times 5 times 2/5. So slightly strange, but I think even when you get to this step, it looks probably easier than the previous example did. Let's evaluate everything that we can. Okay, so over here I've got 2 times 5 times 2/5. I'm going to do the numerical part of it first. 2 times 5 is 10, times 2/5 is 4. So this is just going to give me a 4x. And already it really looks like a quadratic. If I take the 121 over to the right side of the equation and write it with leading terms, 25 take away 121 is minus 96. So I've reasonably quickly got to a quadratic formula. And since the numbers are so nice, I'm going to attempt to factorize. 96 does have quite a lot of factors, so I need to find some that are 4 apart. I know that because this is a minus, I'm going to have a plus and a minus in the brackets. And the combination I think that you guys will need is a 12 and an 8. Tells me either x minus 12 is 0 or x plus 8 is 0. This tells me that I have a side of 12 centimeters, or this one tells me that it could be minus 8. We already know the answer is set up here that it was 12. We just have to justify why it can't be this. And since we're talking about triangles, you might have already spotted this. We're talking about the length of this side. Lengths are positive quantities. It cannot be a negative value. Let's just write that in. Lengths cannot be negative. And ignore that. And then we'll take that as our answer. Yes. Well, thanks for sticking with me, guys. Hopefully it hasn't been too painful, and wishing you a lovely rest of day and a wonderful holidays. Take care.